Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be doing the second part of Chapter 2, Lesson number 1, talking about linear equations. What we're going to be talking about today is different types of linear equations. Last class we talked about how to solve the linear equations, and today we're going to talk about different types of linear equations. We're also going to get into what's called absolute value equations. They are part of the linear equation family, so we'll get into those. And I don't think it'll be too bad, but there's a lot of material to go through, so pay attention and take notes. Something that I haven't talked about a lot is make sure you're taking your notebook. Write down things. That will help you learn. The science, the studies tell us that the more you write down, the more your brain remembers. So take this information, write it down, and it will help you to learn it. All right, let's take a look down here at the board. And by the way, we are on page number 60 in your books, page 60. If you'll take a look down here at the board, it says types of linear equations. Types of linear equations. Now, the first one is called the conditional equation. There is a table in your book. It says Table A. In this book, whenever you see the word table, A, B, C, D, whatever the number, the letter of the table is, it's very important. Okay, they don't put these tables in there for their own health. Okay, they put them in there for you to study, to learn, and to understand the material. They are the most important things in the book. Those tables. If you will take the time and memorize them, look at them, read them, learn them, you will do very well. All right, so Table A, page 60. Conditional. What does that mean? Here's what a conditional equation means. It has finite number of solutions. Finite means it can be numbered. It's not infinite, okay? So usually one. Typically, a lot of these just have one answer. Sometimes they'll have 2, 3, 4 answers, and we'll show you that a little bit later how that works. But here in linear equations, typically they have one solution. Okay, that's usually one solution. The second type is a contradiction. And the word itself sounds like exactly what it means. If you contradict somebody else, then one statement is true and one statement is false. You're saying, hey, that person is not true. This is the truth. Or maybe you're coming up with a falsehood. You're saying, yes, they're true, but I'm going to come up with something that's false. And so you contradict them. Maybe you're both false. Okay. A contradiction, basically saying the opposite of what somebody else is saying. And in this case, in equations, that means that there is no solution. In other words, they're not balanced. The one side is outweighing the other side. They're not balanced. There's no solution. They're contradictory. All right, the next one is identity. And with identity, it means that they have infinite number of solutions. In other words, whatever number you put in, infinity number of solutions. You can put in whatever negative number, you can put in whatever positive number, you can put in whatever fractional number, and it will be a solution. And we'll look at what all these mean. So I wanted to kind of go over them first, and then we'll talk about each one of them. If you want to look there on page number 60, you can. Let's do this one. Let's try to determine what one this one is. 3x plus 2 equals 6x plus 4. All right, so let's just start solving it. Let's do what we can do. Well, one thing that we can do is we can go ahead and distribute right here. And so we have 6x plus 4. 6x plus 4 equals, wait a second, 6x plus 4. That's weird. Okay, never seen one that looks like this before. So let's keep going with that. What happens if we just keep working it? Minus 4, minus 4. Well, watch what happens. That cancels and that cancels. Okay. Minus 6x minus 6x. Well, that cancels and that cancels. Everything canceled. What are we going to do? All right, well, here's what happens. We have 0 equals 0. Well, let me ask you a question. Does 0 equal 0? Yes, the answer is yes. 0 equals 0. But what do you think? What one would you say this is? Did we get an answer? technically we didn't get an answer. We got 0 as an answer. But is it no solution? It's not contradictory. 0 does equal 0, so it's not contradictory. But did we get one solution? Not really. We got 0 equals 0. It was weird. The whole thing canceled out. We didn't get x equals something. So this one is actually an identity. And here's a good way that you can see the identity. Let me erase some of this right here. I want to show you where you can kind of recognize, oh, that's identity right there. If you look at this one, you'll see, look, 6x plus 4 equals 6x plus 4. That's identity. It's the same thing on both sides. And so no matter what you put in, if you want to put in 2, x equals 2, if you plug in x equals 2 and you put in there, right there, guess what's going to happen? 6 times 2 plus 4 equals 6 times 2 plus 4. It's going to be equal. Whoops, I did that wrong. 6 times 2 plus 4. And it's going to be equal. And so if you do that out, you're going to get 12 plus 4 equals 12 plus 4. And then you're going to get 16 equals 16. And no matter what number you put in, you're going to keep getting the 0 equals 0, 16 equals 16, 2 equals 2, 100 equals 100, a million equals a million. It just keeps going on and on and on into infinity. There are infinite solutions, anything you put in. So that's an identity one right there. Okay. Let's look at another one. What happens? We'll do a conditional one. These are the ones that you've done your whole life. These are the ones that kind of look normal to you. 3b plus 2 equals b plus 4. Okay. And so again, we're moving things, trying to get the letters on one side. So we move the b over there. We do minus b, that's going to cancel. And we're going to get 2b. And then if we do minus 2, that's going to cancel, equals 2. And then we divide both sides by 2. And I know I'm going fast here, but you should know how to do this. B equals 1. That's conditional. Why is that conditional? Because we got one answer. Look up here. Finite number of solutions, usually one solution. So we got one solution, b equals 1. That's it. Okay. All right, let's look at another one. Let's look at one that is a contradiction. Let's look at what that looks like. So in a contradiction, we would have a plus 3 equals a minus 2. A plus 3 equals a minus 2. All right, well, that's contradictory. And we can kind of see it right there, but let's work it and let's see what happens here. If we do minus a from both sides, because we're trying to move the a over there, get the letters by themselves, what do we get? We get cancel, cancel. 3 equals negative 2. And right there, we can say 3 does not equal negative 2. What happened to the a? The a went away. The a disappeared. And then we could even try this, minus 3 if we wanted to do that. And we'd get 0 equals negative 5. Well, none of that makes any sense. And that's called contradiction. Basically, we get no solution. That doesn't work. And we could have seen that pretty clearly right up at the beginning. If we looked at this, just like we looked at the identity one, when we look at this one, you should look at that and go, a plus 3 cannot equal a minus 2. Those two things are too different. So let's say a is 5. 5 plus 3 is 8. 5 minus 2 is 3. 8 and 3. No, those aren't the same thing. That's contradictory. Okay? And so that's the different types of linear equations. Make sure you know those and make sure you're kind of familiar with those. Conditional, you have one solution. Sometimes more, but a finite number. There's only a few solutions. Contradictory, no solutions. It comes out weird. 6 equals 2. Well, that's not true. So that's a contradiction. Identity, infinite solutions. That was like this one. Whatever we put in there gave us 16 equals 16, 0 equals 0, 6 equals 6, stuff like that. So those are the different ones. All right, let's go ahead and continue on to the last part of this chapter. And I know we don't have a ton of time left, but this doesn't really take that long. We're going to go ahead and talk about absolute values in linear equations, okay? There's some steps here. And the first thing that you want to do is you want to isolate the absolute value. Isolate the absolute value. And we'll talk about what that looks like in just a second. Number 2, make 2 equations, one with the positive values and one with the negative values. And we'll talk about why we would do that in just a minute. Number 3, solve the equation as usual. So just solve the equations, each one. Solve the negative equation and solve the positive equation. And then last, we're going to check for extraneous solutions. That might be a new word for you right there, extraneous. What does that mean? All right, that means solutions that do not check, not real. Okay, they're not really answers. In other words, we can sometimes get a solution, but when we check the solution, it doesn't work. It doesn't check out. And that's called extraneous. And so that would actually not be part of the solution set, would not be part of our answer. We would actually withhold that, or you could write it and say extraneous next to it. Okay. All right, so let's look at a couple of these. Let's see, our absolute value of r plus 7 equals 13. Absolute value of r plus 7 equals 13. So the first thing that we want to do, if we go up to our steps, it says isolate the absolute value. Isolate the absolute value. Well, let's come here and let's look. Well, there's the absolute value. Guess what? It already is isolated. It's by itself. Okay, you can see it there all by itself. There's nothing else there. So we're good. We're done with step 1. That was easy. I like easy steps. Number 2, make 2 equations, one positive and one negative. I told you I was going to explain this in a minute, so here's the explanation. Why do we make 2 equations? Well, because absolute value, remember, if we have absolute value of negative 5, what does that mean? That equals 5 positive. So, in other words, this r could theoretically be negative 5. It could. That could be an answer. And if it is a negative 5, then we would have to solve inside of it and figure it out. So, in other words, it could be positive, it could be negative. And so we're going to solve for both potential solutions there, both potential paths, if it's positive or if it's negative. So we're going to do one positive. So we'll just do this one, r plus 7 equals 13. Now over here, we're going to do one negative. Now be careful with this one because we're going to have to distribute this negative sign. Negative r plus 7 equals 13 because we want this whole thing to be negative. We want both of those to be negative. We're not just making a negative r, we're making everything inside of it negative. And in order to do that, we have to distribute. So let's do this negative one first, okay? So we'll distribute that negative and we'll get negative r minus 7 equals 13. Now we will go ahead and add 7 to both sides following our steps that we learned in the last lesson. That's going to cancel and we're going to get minus r equals, then we'll add those together and that is 20. Now what we need to do here is that is not a good solution because we don't want negative r equals. We want positive r equals. Now what's in front of every one of those? There's a 1. So we need to divide by a negative 1 both sides. And if you divide by a negative 1, that will cancel and give you positive r or just r equals, and then this is going to give us a negative 20. So there's one solution. That's the negative side of the solution. And then let's go over here and do the positive side. This one's a whole lot easier. So we're just going to go minus 7, and we're going to get r equals, that's going to cancel, and do that right there, and you get what? Okay, r equals 6. R equals 6. All right, so now we have 2 solutions. Remember what I said. We're almost done. And so step number 4 is check for extraneous solutions. Let's see if both of these work. And the way that we would do that is we would take them each separately and we would put them back into the original problem. So we would say absolute value of, let's do the 6 first. We'll do the positive one first. So 6 plus 7 equals 13. Does 6 plus 7 equal 13? It does. So 13 equals 13. That one checks. So we're good over here. The 6 checks. Okay. And so now let's do it with the negative 20 and see what happens. Some of you are thinking, there's no way. 2 answers can't check. Just wait. Because of the absolute value, some things are different here. So let's do the negative 20. That's our solution over here. So negative 20 plus 7. Don't forget that's absolute value equals 13. What is negative 20 plus 7? Remember the steps. We would subtract, take the sign of the largest. Negative 13. Don't forget that's still in absolute value. What is the absolute value of negative 13? Well, it's 13 equals 13. Wow, cool. So we had 2 different answers and they both checked. Now sometimes you'll get one that doesn't check, and if you do, that's extraneous and you just wouldn't use that one. Okay? All right, a little bit longer lesson today. I try to keep it around 15 minutes, but sometimes it goes a little bit longer, and today did. But today we had quite a few things to get through. I hope you learned something today. If you missed anything, roll back there and watch it again. All right, we'll see you later.